All right, one more time. Let's do it again. So we've got standard form y equals ax squared plus bx plus c. So I can tell in this one that my a is a -1. I'm just too lazy to write that 1. My b is what's in front of the x, so my b is -2. And the c, there's no constant term here, so my c is 0. So when I go to plug and chug this in, to my axis of symmetry, x equals -b/2a. And again, there are different ways of attacking. Later on, you might be more comfortable factoring first. Totally fine. But if you want a plan of attack, this can be it. So we're doing -b/2a, plugging that in. We've got our axis of symmetry. Since our vertex is going to be on that axis of symmetry, we already have the x value. We're just going to plug that in to find the y. So whatever you just got, plug it in to find the y. So -1 plus 2 is 1. So when x is -1, the y is 1. That is our vertex. We go here and let's see, we can plot what we've got. So the axis of symmetry is x equals -1. The vertex is -1, 1 right there. When we go for our y-intercepts always happen when x equals 0, no matter what graph you have. So if you plug that in to our equation, we get 0 minus 0, which is just 0. And so we've got a point right there. We can plot it on a point on the other side for free because of the axis of symmetry, nice and symmetric, which means for part 4, I already have my x-intercepts if I've been taking the time to graph them. I can see my x-intercepts are -2, 0, and 0, 0. But you're like, well, what if I haven't been graphing it? Then you can always get an x-intercept by making the y be 0. So my original equation was y equals -x squared minus 2 times x. If I let the y be 0, I can solve this. It's a quadratic. We can solve this either by factoring, or if you don't like factoring, or if it doesn't factor, quadratic formula is always there for you. So factoring GCF first, I can pull out a -x from both of those. They're both divisible by x, and I'd get x plus 2. If you don't believe me, you can distribute it back in and you match. Hooray. And then the beauty of factoring is if this times this equals 0, then either this equals 0 or that equals 0. No other way to make a 0. So either x is 0 or x is -2. And hey, look, that matches the x-intercepts that we got. Awesome. If you didn't like that factoring and you prefer to do quadratic formula, I do not recommend it. Factoring was very fast and useful, but if you want to do quadratic formula, I'll show that it works. So you can do your -b, so +2 plus or minus the square root of b squared. What was my b? Oh yeah, b squared would be 4 minus 4 times a times 0 all over 2a. And then, let's see, I have 4 minus 0 is 4. That's underneath the square root, so that's 2. So we have 2 plus or minus 2 all over -2. So if it's 2 plus 2, that's 4 over -2. If it's 2 minus 2, that's 0 over -2. So then x is going to be either a -2 or a 0, which is exactly what we got there. Hooray, hooray, huzzah. When we go to sketch, we've already got kind of enough points. If you want, you can just do a nice little sketch. But if your teacher wants more points, we can always make a little XY table and plug in some more. So the x, and then the y is -x squared minus 2x. And then we'll do x, y, our ordered pair there. You want to plug in points that are close to your vertex because that's where the interesting stuff is happening. I already know these guys, so maybe I'll plug in a 1 over here. So if I plug in a 1, I'll get y equals negative 1 squared plus 2 times 1, which is negative 1 plus 2, which is 1. Oopsie. Something funny happened there. Did I? Oh, I copied my problem wrong. It was minus 2x. This should be minus, which makes that minus, which makes that minus. So negative 1 minus 2 is negative 3. So I have 1, negative 3. And when I go to graph 1, negative 3, that looks much more reasonable. And then I go plot it on the other side, nice and mirrored, and I can sketch a parabola. Ta-da! All right.